AI is writing code. AI is generating content. AI is assisting doctors in diagnosis. AI is running a business. AI is answering customer calls. AI is driving cars. So you might be wondering, how did AI get so good so fast? Let's rewind and see how AI got so good. Let's look at AI's journey. Let's go back in time. The idea of machine learning was born in the 1950s. Arthur Samuel, the first program that taught itself. Checkers. ML never took off. Data and computing power weren't there yet. By the 2000s, the internet created an explosion of data. The fuel machine learning needed. ML learned to spot spam emails on its own. Netflix paid $1 million to make its recommendations smarter. ML learned to understand your voice. Siri arrives. Machine learning was powerful, but limited. It needed humans to handcraft features with constant manual. Tuning plateaued more. Data stopped helping. Struggled with images, speech, and language. Neural networks that learn on their own. The birth of the perceptron. Introduced by Frank Rosenblatt. A perceptron takes inputs, processes them, and makes a simple decision. But perceptron's biggest limitation, it could only handle linear classification. Deeper networks needed better training, more data, and faster computers. Deep learning, perceptron-like neurons, stacked into many layers. This is how a neural network builds understanding, one layer at a time. Backpropagation, 1974. The network learns from its own mistakes, finally giving neural networks a way to improve. LeCun's neural net reads handwriting for banks. ImageNet collected and labeled 14 million images for AI. AlexNet, the deep learning revolution, powered by GPUs and ImageNet. AlexNet achieved breakthrough accuracy, which changed AI forever. Millions of images went in. Layer by layer, the network learned edges, shapes, textures, and objects. AI beats the world champion in Go. AI reads scans like an expert. AI learns to see the road. AI solved how proteins fold. Machines could now see, hear, and understand. But soon, they would learn to create. Generative AI learns from millions of examples to create new text, code, audio, and images. In 1966, Eliza became one of the first chatbots, and people opened up to it like a real therapist. Eliza didn't understand anything. It just spotted a keyword and flipped your words into a question. People grew so attached to Eliza they shared their deepest feelings to it, even after knowing it only matched keywords. GAN. In 2014, GAN, a new idea, changed everything. The creator builds a human face. The verifier inspects every detail. Each flaw teaches the creator to improve until the fake looks perfectly real. GANs taught machines to invent, not just copy. AI was creating on its own. Faces of people who never existed. Sketches became real objects. A horse could become a zebra. Rough shapes became whole worlds. Attention is all you need. A new idea was about to reshape everything AI could build. Before 2017, AI read one word at a time. With attention in 2017, AI could see every word at once. For every word, attention asks which others matter. So AI knew was meant the cat. Attention was just an idea. Here is the transformer architecture that made it work. Transformer has an encoder block and a decoder block. Attention tied them together. The encoder is the reader. It understands each word from the words around it. Knowing where to look, that is attention. It turns the whole question into meaning and hands those notes to the decoder. The decoder is the writer. Each step, it reads the notes and the words written so far. Then it predicts the next word and repeats. For the last word, attention locks onto Hamlet. The notes never held the name, but the model does. Memory recalls Shakespeare and writes it in. Attention finds what to look at. Memory supplies. Using attention transformers unlocked parallelism. Reading every word at once. So training became faster. Faster training allowed models to scale. Bigger models with more data and more power. Now we could feed them text from everywhere. Everything from across the internet. The transformer had changed everything. This design could now do almost anything. One architecture, endless possibility. In 2018, OpenAI introduced GPT-1, the first generative pre-trained transformer. It was trained in 2 stages. First, it read over 7,000 unpublished books, predicting the next word again and again. No labels, just raw text to learn from. Then, it was fine-tuned for specific tasks, like sentiment analysis and answering questions. But you could not simply ask it anything. Every task needed its own special retraining. That took labeled data and real expertise. Its writing was clumsy and often lost the thread. GPT-1 was just a quiet proof of concept, small, limited, and easy to overlook. But this was the first time a machine learned language and adapted it to any task. In 2019, OpenAI released GPT-2, the same design, but 10 times bigger. Over 1.5 billion parameters trained on the internet. And its writing finally felt real. It could even attempt tasks it was never trained on. But it still made things up and lost its way. Convincing, yet not quite reliable. So convincing, OpenAI held it back, fearing misuse. Then, quietly released it months later. In 2020, OpenAI unveiled GPT-3, 175 billion parameters, over 100 times GPT-2, trained on much of the internet, books, and Wikipedia. This time, something new emerged. You could teach it right inside the prompt. Show it a few examples of a task. And it instantly did the rest. No retraining. This was few-shot prompting. Suddenly, one model could do it all. Translate, summarize, and answer questions. Write essays, poetry, and even code. Fluent enough to feel almost human. But it confidently made things up. It could not truly reason or handle simple math. It had no memory beyond its training. And it echoed the internet's biases. Give it a few word pairs to translate. And it continued the pattern perfectly. But ask who first walked on the sun, and it might invent a confident false answer. GPT-3 was powerful, but locked away. A tool for developers, not the world. Most people had never even heard of it. Then in November 2022, the world woke up. OpenAI launched ChatGPT, a conversational interface built on GPT-3.5. 1 million users, a record at the time. 100 million in 2 months. Growth, no product it matched. Developers, researchers, everyday users poured in. The world now talked to a machine. From research to reality, in everyone's hand. But why did ChatGPT break through? The technology had existed for years. So what made this one different? For the first time, you could just talk to it. No prompts to engineer. You asked, and it answered. It followed you like a real conversation. Older models had knowledge, but they truly could not understand. So how did it learn to listen? The secret was human feedback. On its own, the model could write. But it didn't know what a good answer looked like. So, people taught it by example, writing ideal answers to show how to respond, then ranking its replies from best to worst. Those rankings trained a second AI, a reward model that learned what people liked. It could now score any answer automatically, and the main model kept trying to score higher, improving a little more each round, slowly learning what humans really wanted. This loop was called RLHF, learning from human feedback. So how did it really understand you? Say you asked book a table by the bank. Does bank mean money or a river? Attention looks at the other words. Table and book hint at a place to eat. so it picks the right meaning from context. That is, attention, understanding your words. Then RLHF taught it what to do with them. People showed it that book means reserve. Not explain the word, just take action. Attention, caught your meaning. RLHF caught your intent. Together, they made it feel like it understood. Built on transformers and human feedback, ChatGPT was the spark that started it all. The moment generative AI truly began, a wave that reshaped every field. And now, AI can do everything